Hello, students. Well, I'm re-recording assignment 10.3 for the simple reason I made a mistake in the first version. No students point me out, but I discovered it because some of you actually got the correct one and I start to mark. The thing is, if I when I was marking very fast, sometimes if I check and I mark you correct when you're supposed to be wrong, or if you are supposed to be wrong and I mark you correct, just let me know and I'll amend the marking. All right. So sorry about that. If it caused you any confusion, but yes. So in the first version, I actually made a little mistake because probably lack of coffee, right? When I was actually preparing this video, so I saw the marking wrongly. So let's try again. So in this particular assignment, what we're supposed to do is we are supposed to find the gradient of each of these 5 lines, as well as to find the equation of lines 1, 3, and 4. Now, I actually, in the previous version, I actually find the equation of all 5 lines because why not, right? I'm going to do the same thing here. Okay, so let's pull out my pen. Let's put my pen, all right? Gradient of the first line, right? So the first line is where the gradient I made a mistake in my earlier video, so I've actually deleted that so that I don't confuse people. But if you look at line number 1, right? Okay, what we can see quite clearly, let me change the color pen, is that the rise and the run, okay, they are 1 unit each, right? The difference is the line is actually sloping down, therefore the rise is actually negative, so it will be negative gradient in the end. So if you just look at that very cleanly, the gradient of line 1 is actually -1 for the rise over the run, which is 1 unit, which will result in -1 unit. Okay, so that's actually the correct version. So what's the equation of line 1? Well, now that we have the gradient, what we need is actually the y-intercept. So to find the y-intercept, right, we know that it is of the version, the straight line is y equals to mx plus c, right? And what happened is we can just choose a single point on this line. So we can simply just maybe take this point that I'm marking it out. So that's when x is -4, right? When x is -4, y is 2. So I can just quickly substitute this in, right? So when x is -4, over here, my m is -1. Okay, let me write it neater. Okay, let's start with m, right? So m is, let's start with y. Y is a 2, m is -1, x is -4, plus c, right? So we work this one out. My c is actually 2 minus 4, -2. Okay, so therefore the equation is y equals to -x minus 2, right? That's the equation. Okay, so this is the correct version, right? Question 2. Line number 2. Line number 2 is a horizontal line. We know straight away the gradient is 0, right? The equation now, right? The equation is a y equals to, well, we just check, right? 1, okay? Because that is the y-intercept, okay? So that this one is a very straightforward, shouldn't be an issue, right? So for the third line again, right? So you see this portion here is a bit difficult to figure out what exactly the value is. So we don't really need that point, right? We can just choose this point and this point as I mark it out on the screen, right? So if we do that once again, the rise is 1 unit, the run is 1 unit, it is sloping upwards. Therefore, the gradient is 1 over 1, which is equals to 1, right? And the equation, using the same idea now, but this time round, we can see straight away that the y-intercept is actually at 2. So we have y equals to x, right? 1x, you can just write x plus 2. Okay, now line number 4. Line number 4 is the more challenging one, right? So line number 4, let's look for 2 points that we can use. Again, in this case, I don't see obvious 2 points to use, right? It's not so useful. So what we can do is we can choose a line that is suitable. So maybe just grab this point, right? So what is this point over here? This point over here is let's take a look. It's in between 0 and 1, so it's 0.5, right? And the y value is 2.5. Okay, so that's fine. And then we can maybe use the other end, right? So the other end over here, okay, we have the x value is 2.5, the y value is negative 2.5. So we can use the formula to find the gradient. In this case, it is 2.5 minus negative 2.5. We can do that over 0.5 minus 2.5. Okay, that will give us 5 over negative 2.5, which is equals to negative 2. Okay, so we have that. Then we need to, of course, find the y-intercept. So we know that y equals to mx plus c. Right, let's substitute with the values we know. We can use the first point. So y is 2.5. My m now is negative 2. My x is when y is 2.5, x is 0.5 plus c. Right, so 2.5 equals to negative 1 plus c. C is actually equals to 3.5. Okay, so when we do that, then our equation y will be equals to negative 2x plus 3.5. Okay, right, finally line number 5. Now line number 5 is a vertical line. There are a couple of students who actually wrote down 0. I guess it's quite easy to confuse horizontal line and vertical line. Gradient of horizontal line is 0. Gradient of vertical line is not 0. In fact, it's undefined, right? Because the run is 0. We cannot divide by 0 when we are trying to calculate the gradient. So actually, the correct word to describe it is undefined. Did I spell it correctly? No, I did not. Let's try again. Undefined. This is the correct word we use describing a situation like this, right? But so the equation, in this case, it will just be x equals to 2.5, right? So that will be the equation. Right, so that's the correct version of assignment 10.3. I hope you are successful. And if I'm not enough coffee when I was making the first version, so yeah, pardon me for that. So if you need me to look at your scripts again to amend my marking, do look for me. I will change it accordingly, right? So for those students who did it successfully without referring to my explanation, congratulations, well done. All right, have a nice day.